All right, so in this lesson, we're ready to talk about some double and half angle identities. So the first one we'll look at is sine of a double angle, so sine of 2x. And to put the identity together, we'll go ahead and view it as sine of x plus x. And now we have sine of a sum. So sine x cosine x plus cosine x times sine x, which, as you can see, those are the same. So like terms tell us we have 2 sine x cosine x, and therefore sine of the double angle is going to be 2 sine x cosine x. For cosine of 2x, we'll do pretty much the same thing. We'll view this as cosine x plus x. Cosine of a sum would be cosine x minus sine x, which gives us cosine squared x minus sine squared x. So cosine of a double angle is cosine squared minus sine squared. Do not get that confused with cosine squared plus sine squared, which we all know is the fundamental identity, and equals 1. The next one, tangent of 2x. We'll say tangent of x plus x. Tangent of a sum gives us tangent x plus tangent x divided by 1 minus tangent x, which gives us 2 tangent of x on top, and 1 minus tangent squared of x in the denominator. So tangent of our double angle is going to be 2 tangent x over 1 minus tangent squared x. All right, so double angles are pretty easy. The half angles, we'll work a little bit harder on coming up with them, but I think it's something that flows pretty nicely. So to do this, we'll start with the cosine squared minus sine squared equals cosine 2x, so the double angle. And we're going to need to do this 2 different ways, so that's where the vertical line on your paper comes into play. The first thing I'm going to do is I'm going to go ahead and I'm going to convert cosine squared to 1 minus sine squared. So just using the Pythagorean identity, this guy right here is that red underlined piece. And by combining like terms on the left, we have 1 minus 2 sine squared x equals cosine of 2x. And now I'm just going to move some things around. I'm going to go ahead and say that 2 sine squared x is actually going to equal 1 minus cosine 2x. So again, follow me on moving things from side to side and having the correct signs. So 2 sine squared equals 1 minus cosine 2x. And then if I divide by 2, I get sine squared x equals 1 minus cosine 2x over 2. Now, this is a really important identity. It's not a half angle identity. In fact, it's not one that comes up all that often throughout this textbook, but it is one that you'll need to know pretty well moving forward. So I'll go ahead and box that one in, but I want to also continue to move down a step now and talk about the half angle identity. If I take all of the angles in the entire identity and if I divide it by 2, it now does give me sine squared of our half angle. And since what I had boxed in red was an identity, dividing all of the angles by 2 is perfectly fine. This will give us 1 minus cosine of x all over 2. So there's a representation for a half angle. I honestly try to remember them like this. If you needed to get sine of the half angle all by itself, you could of course square root both sides. Just don't forget the plus or minus. Okay, now on the other side of the argument here, I'll go ahead now and take this guy, and instead of changing the cosine squared into 1 minus sine squared, I'll take the sine squared and turn it into 1 minus cosine squared. So cosine squared x minus 1 minus cosine squared x equals cosine of 2x. If I distribute and clean things up here, I'll get a 2 cosine squared x minus 1, there we go, equals cosine of 2x, which then tells me that 2 cosine squared x equals 1 plus cosine 2x. When we divide by 2, we end up with 1 plus cosine 2x over 2 is equal to cosine squared x. Again, not one that's mentioned a whole lot in the text. You'll use it rarely in the homework, but it will come up occasionally. But it's one that will come up a lot moving forward into future courses. So that's a good one to know. And then similar to how we worked the other one, if I go ahead and divide everything by 2, that gives me the true half angle then. So 1 plus cosine x all over 2. And then similar to the other one, if you really did need cosine of half angle all by itself, you could square root, and don't forget the plus or minus there. But there's several good identities there in this breakdown. Again, the red ones will surprise you and how often they come up in future courses. The black ones you'll use from time to time in this homework as well. All right, so for the tangent of a half angle, we're actually going to start with tangent squared, and you could probably understand why pretty easily from the last couple we worked. We want to avoid those square roots, especially in deriving it, because it's not really necessary to burden ourselves with that. So tangent squared of x over 2, well, that would be your sine squared of the half angle over the cosine squared of the half angle. For the sine squared that we just came up with of the half angle, it's going to be 1 minus cosine of x over 2. For the cosine squared to be 1 plus cosine x over 2. Multiply by 2 over 2, and all of that goes away, leaving us with tangent squared of the half angle as 1 minus cosine x over 1 plus cosine x. So then, once again, if we wanted the half angle of tangent all by itself, we'd have this plus or minus 1 minus cosine x over 1 plus cosine of x. So there is one of your identities for tangent of a half angle. Now, the other two that we're going to come up with, we actually have 3 identities for tangent of a half angle. The other ones all start with this guy, but they simplify down and create something much nicer. So I'm going to go ahead and clear the screen and reset it up with the identity on top that we're going to start with, and then show you how this breaks down. Okay, so to make this look a lot nicer, what we're going to do is I'm going to go ahead and extend out the radical there, and I'm going to multiply top and bottom by 1 minus cosine of x. Again, perfectly legal, and it might seem random, but it should work out quite nicely if we continue on. So we'll have a plus or minus in the numerator. I'm not going to multiply that out, but instead I'll call it 1 minus cosine x quantity squared. In the denominator, when I multiply this out, I get 1 minus cosine squared x. Now, again, in the numerator, I'm just going to leave that alone. In the denominator, I can see that that's going to be sine squared. So algebraically, I'll split up the radical, 1 minus cosine of x squared, square rooted, and then the square root of sine squared x. Now again, algebraically speaking, the square root and the square do away with one another. So technically it leaves us with 1 minus cosine x over sine of x, kind of. Because we do have to remember there's a plus or minus out in front of here. And so by just doing away with the radicals like we did, we do potentially run the risk of missing out on some signs. Now, fortunately, it all works out nicely to where you can drop the plus or minus. It's not an obvious reason, but it is one that's assigned in the homework, so I'll let you guys give that a little thought when the opportunity presents itself. So bottom line is tangent of x over 2 ends up equaling 1 minus cosine over sine without any radicals needed, without any plus or minuses, or without any squares needed. Now, similarly, let me come back up here. I'm going to go ahead and erase this stuff. And instead of multiplying by 1 minus cosine x, now I'm going to do 1 plus cosine x. And you'll see that pretty much the same thing happens. In the numerator, I'll get a 1 minus cosine squared. In the denominator, I'll get a 1 plus cosine x quantity squared. I'll split that up, and I'll have a sine squared on top. On bottom, I'll have the square root of 1 plus cosine x quantity squared. And then, just like the last time, for the same reasons, in fact, that you'll see in the homework, you'll end up with sine of x now over 1 plus cosine of x. So tangent of x over 2 has now a third identity.